Welcome back to the channel. In today's lesson, we'll be seeing how to find the equation of the tangent to a curve with an implicit function. In our last lesson, we explained how to find the differential of an implicit function. In case you missed that lesson, we have placed a link in the description below. Now that said, let's get started with finding the equation of the tangent of an implicit function. Our question says, well, we should find the equation of the tangent and normal to the curve with this equation below. Our question says we should find the equation of the tangent and normal to the curve with this equation: x squared plus y squared plus 3x minus 11 is equals to 0. The first thing is to differentiate this implicit function. Like I said initially, we have placed a link in the description to our lesson on how to differentiate implicit function. Now, the first thing is to differentiate this. We differentiate the x squared, we differentiate y squared, we differentiate our 3x, y, and we also differentiate our minus 11. Now, to differentiate our x squared, remember that when y is equal to ax raised to power n, we'll say that our dy dx from the formula is equal to anx raised to power n minus 1. So that for my x squared, the differential of the x squared will be 2x. Plus, for my y, when differentiating my y raised to power 2, I'll pick one of the y's and I'll differentiate the other. It becomes dy dx. But do not forget the raised to power 2. Now this is 2y, dy dx. Plus, here I have 3 into, now I have x and y. This is where it might get a little confusing, but you don't have to worry. Just follow me one after the other. Now, the first thing is to differentiate the x. If I differentiate x, x becomes 1. I'll keep y. Plus, I'll now differentiate y and I'll keep x. This becomes x dy dx. Bracket close. 11 is a constant, so it becomes 0 equals 0. Now my 2x, let me open the bracket so that I could write it appropriately. 2x plus 2y dy dx plus 3y plus 3x dy dx equals 0. The next thing is to collect like terms. I'll be collecting like terms so that my 2x plus 3y, they are alike, plus 2y plus 3x now into dy dx equals 0. Now, so that my 2x plus 3y dy dx should be equals to, let me check this, 2x should be equals to, now minus 2x plus 3y. Is it 2x? Please let me check that. Okay, this is, oh, sorry, this is 2y plus 3x into dy dx. That means I have to remove this. That's 2y plus 3x into dy dx. I made a mistake collecting. Now, so that we now have my dy dx to be equals to minus 2x plus 3y all over 2y plus 3x. Remember, this is at the point P where my x is 1 and my y is 2. So that at that point P, that becomes minus 2 into, that's 2 into 1 plus 3 into 2 over 2 into 2 plus 3 into 1. Now this is y here. So that this is the same thing as minus 2 times 1, that's 2, plus 3 times 2, that's 6, over 2 times 2, that's 4, plus 3, that's equals to minus 8 over 7. Now that's my dy dx at this point. Obviously, that's my slope. So from our lesson on how to find the gradient, or how to find the equation of a straight line, we said that my y minus y2 minus y1 over x2 minus x1 is equals to m. That's a slope. Is equals to the slope. So that my y now minus, in place of y2, let's use y minus 2 over x minus 1 will be equals to the slope, which is minus 8 over 7. So that y minus 2 is equals to minus 8 over 7 into x minus 1. So that y will be equals to minus 8 over 7x minus y plus 2. So that my y now for this equation will be the same thing as minus 8 over 7x minus 1. Okay, sorry, this is not minus 1. Minus 8 over 7x times minus 1 becomes plus 8 over 7. That was a mistake on my part. So that this is the same thing as minus 8 over 7x plus, that becomes 3 whole number 1 over 7. Let's expand. I'm not with my calculator, please permit me. Over 7x, 7 times 3, that's 21, plus 22 over 7. That is equals to y. So invariably, I can say that my y is the same thing as, or invariably, I can interpret my equation to be 7y to be equals to minus 8x plus 22. Now, this is the equation of the tangent. Now, let's solve for the normal of this equation. To solve for the normal, we know that my m1, m2, since the normal and the tangent are perpendicular, is equal to minus 1. So that my m1 into the gradient of the tangent was minus 8 over 7 is equal to minus 1, which implies that my m1 will be the same thing as minus 1 times 7 over 8, negative. Negative multiplies negative becomes positive, so that my m1 for the normal is the same thing as 7 over 8. Now we can now use our equation, since we're dealing with a point P at 1 and 2, and our gradient m1 is the same thing as 7 over 8, we can say that y minus 2 over x minus 1 is equal to 7 over 8. Let's cross multiply. So that 8 into y minus 2 will be the same thing as 7 into x minus 1. Now 8y minus 16 will be the same thing as 7x minus 7. Now 8y obviously is equal to 7x minus 7 plus 16. 8y will be the same thing as 7x minus 7 plus 16. I think that's plus 9. If I'm not mistaken, that's plus 9. So that divide both sides by 8, I have y to be equal to 7x over 8 plus 9 over 8. Now, you can take any of these two as the equation of the normal. With that, we've been able to see how to solve for the equation of both the normal and the tangent where the curve is an implicit function. If you have any question, please do not hesitate to use the comment section. I'll be there to respond to your question. Thank you for staying with us and have a nice day.